We're all taught to solve big problems by breaking them down into small, manageable steps. But what if that very approach is the reason so many projects just fail? What if taking it one step at a time is actually a march toward disaster? Well, today we're going to explore a really powerful shift in mindset, moving from isolated, siloed thinking to seeing everything as one big integrated system.
So, the old way, it's kind of like a relay race. Each person runs their part of the race completely alone and only passes the baton at the very end. It's totally linear, it's disconnected, and you basically just react to problems as they pop up. But lifecycle thinking, that's completely different. That's like the entire team is on the field together from the very beginning, strategizing and adapting in real time. It's proactive, it's integrated, and it sees the whole race, from start to finish.
And that's where things really start to fall apart with the old way. See, when different stages of a project aren't talking to each other, a design that looks absolutely brilliant on paper might be impossible or just crazy expensive to actually build. But with that old linear approach, you're not going to find that out until it's way too late and way too costly to fix. All right, so here's our game plan for today. First, we're going to dig into why that old linear way of thinking is just fundamentally broken. Then we'll introduce the solution, thinking in full life cycles. And we're going to see how this one powerful idea is already transforming physical products, massive buildings, and even the future of AI. So stick around to see how it all connects.
Okay, first up, the old way is broken. You could also call this the flaw in the straight line. Let's take a look at how this plays out in a classic engineering scenario. This is what's known as sequential engineering. The design team works in its own little bubble to create what they think is a perfect blueprint. Then they just throw it over the wall to the manufacturing team, and it's their job to figure out how to actually make the thing. It seems logical, right? But in reality, it creates these massive bottlenecks. And the consequences are, well, they're predictable and they're always expensive. The manufacturing team might find a tiny design flaw that sends the entire project back to square one. This siloed approach leads to huge delays, costs that spiral out of control from all those late-stage changes, and communication just completely breaks down. And the end result? It's usually a lower quality product that gets to market way too late.
So, if that straight line is broken, what's the alternative? Well, this brings us to the hero of our story, thinking in full life cycles. This is the paradigm shift.
At its core, lifecycle thinking is a really simple but incredibly profound idea. It just means considering every single stage of a system's journey, from the raw materials used to create it, through its manufacturing and use, all the way to its final disposal or recycling. The absolute key is to think about that entire journey from day one.
We can basically boil this down to three main pillars. First, you have to see the whole journey, from cradle to grave. Second, unite all the different disciplines. The designers, engineers, manufacturers, everyone. They're all in the same room from the start. And third, you plan for the future, proactively thinking about challenges that might pop up years or even decades down the road. Okay, so that's the theory. But how does this mindset actually change things in the real world? Well, our first case study looks at how it's used to build faster, smarter products. So in the product world, they call this concurrent engineering. Instead of that linear relay race we talked about, it's a process where design and manufacturing are developed in parallel at the same time. The manufacturing expert can literally give the designer immediate feedback saying, hey, if you just change this one little angle, we can produce it twice as fast and for half the cost. And the results they're pretty dramatic. By running these processes side by side, companies can get products to market so much faster. Costs plummet because expensive problems are caught super early. And because you have all the experts collaborating from the start, the overall product quality goes way up. It's a clear win-win-win across the board. So this thinking works for products, but can it really apply to something much bigger and way more complex, like a skyscraper? Oh, absolutely. Let's look at how we assess buildings for a greener, more resilient future. The first thing you have to wrap your head around is the timescale. To properly assess a building's environmental impact, the standard isn't 5 or 10 years. It's 50 years. 50. That kind of long-term view forces everyone involved to think far, far beyond just the initial construction. And a 50-year life cycle, it includes everything. It's not just the carbon footprint of the materials and the construction itself. That's only the beginning.
It also includes all the energy the building will use for heating and cooling over decades, plus any repairs and maintenance. And finally, it even accounts for the environmental cost of demolishing the building at the very end of its life.
Now, this is where it gets really complex, and you see why this proactive planning is so crucial. A true life cycle assessment has to deal with these huge uncertainties. I mean, what if the electricity grid becomes fully renewable in 30 years? That would dramatically change the building's operational emissions. What if climate change leads to hotter summers, requiring way more energy for cooling? Life cycle thinking forces you to model these future scenarios today. All right, let's take a leap to our final and perhaps most abstract example: developing artificial intelligence. This isn't a physical product, but the exact same life cycle logic is absolutely essential for creating safer, more ethical AI. You know, a common mistake is to treat AI ethics like some simple checklist you just run through before you launch. But a real framework is a governance model that is embedded in the entire process, from the moment you decide to build an AI, through its development, its deployment, and its ongoing monitoring. A really powerful way to structure this is the 3 lines of defense model. The first line is the project team, the people doing the hands-on work and the initial risk assessment. The second line is an independent group that reviews and challenges their work, providing crucial oversight. And the third and final line is senior leadership, who are ultimately accountable for the AI's impact. You see, this structure builds in checks and balances at every single stage of the AI's life. And this entire life cycle is guided by core principles. Things like fairness, to make sure the AI doesn't just amplify existing biases; accountability, to clearly define who is responsible when things go wrong; and human oversight, to always keep a person in the loop. By embedding these from the start, they become foundational to the AI's DNA, not just some afterthought. So we've looked at products, buildings, and artificial intelligence. 3 totally different worlds, right? But they're all being transformed by the same core idea. So let's wrap this up by focusing on this integrated mindset. So what's the common thread that links all these examples? It's really a shift in perspective. It's about adopting a holistic, end-to-end view of everything. It's about managing risks proactively instead of just putting out fires. It requires bringing different kinds of expertise together from the very beginning. And, crucially, it's about focusing on the long-term impact, not just short-term goals. And ultimately, that's the key. Lifecycle thinking isn't just another methodology or some new corporate buzzword. It's a fundamentally different way of seeing the world. It's a mindset for untangling the deeply interconnected, complex challenges we face today, from building a simple product to shaping our future with AI. We've seen how this integrated mindset is making our products better, our buildings greener, and our AIs safer. It forces us to see the whole system, not just the individual little pieces. Which leaves us with one final, big question: what other complex problem should we apply it to next?